Good morning, children. How are you? I hope you all are fine. Welcome to today's mathematics class. Okay, so finally we completed the chapter algebraic expression. So today we are going to revise the whole chapter. Okay, today we are going to revise the whole chapter algebraic expression, page number 229 to 247. Okay, see algebraic expression, that is already we just discussed this about in the chapter symbol equation, right? Anyway, see variable, the main part of this variable. What is mean by variable? A variable can takes various values, that example alphabetic letters. So variables means we can give values according to our wish, according to the question we can change the value. So for example of the variable is alphabetic letter, we can say ABCD etc. Here a we can give any value, right? If you want we can give a value is 1 or 5 or 10, whatever may be. So it is known as variables, that is it can change, it has various values. Okay, then about constants. Constant has a fixed value, the value never changes like variable, it is a fixed values. Example numbers, we can say numeric, right? It is 1 2 3, we can call it as 1. Okay, so that's the difference between variables and constants. What is variable? It varies its value. Constant is a fixed values, right? With the help of these variables and constant only we can make a expression. Okay, so see what is expression? The combination of variables and constants with four fundamental operation is an expression. The combination of variables and constants with four fundamental operation is an expression. Okay, with the help of four fundamental operation, what is the four fundamental operation? Addition, subtraction, multiplication and division. So with this variable and constants, the help of these four fundamental operation, we can form an expression. Example x plus 9, here addition, right? X plus 9. Y minus 7, here subtraction. And 5x plus 3, here multiplication as well as addition. 5x means 5 into x multiplication plus 3 addition. Okay, and then 2p by 7, that is division, multiplication as well as division. Okay, and see expression are made up of terms, that is see terms are ordered to make an expression. For example, if it is 1 times or 2 times, whatever may be, we will call it as an expression. See here, first example, 4xy minus 5x plus 7x is there. How many times are here? 3 times are there. 4xy, 5x, 7xz plus 7yz. That is, sorry, 4 times are there. 4xy minus 5x plus 7xz plus 7yz. 4 times are there. Okay, here the terms are separated by the addition and subtraction symbols, right? So expression are made up of terms. A term is a product of factor. Factor, what is a factor? A term is a product of factor. Example, see term 7 is yz in the above expression. What is the above expression? 4xy minus 5x plus 7xz plus 7yz is an expression. In this expression, we took only the term 7yz. Okay, here we are going to find the factor of this term. What are the factor of this term? What factor we said? A term is a product of factor. Okay, so factor of this term is 7, y and z. Three factors. Okay, 7, y and z. Factors containing variables are said to be algebraic factor. Here only we are taking a factor as a variables. Only variables means we can call that factor as a algebraic factors. And then see coefficient. Now we are going to discuss about coefficient. What is coefficient? The coefficient is the numerical factor in the term. Sometimes any one factor is a term is called a coefficient of remaining part of the terms, that we will see an example. Usually coefficient means numerical factor in the term. Suppose you may get only one term and they will ask to find a factor of a particular variable. Okay, for example, see find the coefficient of y in minus 6pq or xy. Here only one term is there, but so many variables are there, right? Minus 6 pq or xy, pq or xy, totally 5 variables, but they told you to find the coefficient of only y. Okay, so how will you write? Except y, we need to write the remaining all as a coefficient of this term. Okay, except y, we needed to write all the remaining coefficient, sorry, variables as well as numerical for coefficient of this. See The coefficient of y is minus 6 pq or x. Minus 6 pq or x. Particularly if they told you to find a coefficient of a particular variable, we just take the term and write only the terms except the particular variable. Okay. See one more example. See, identify the numerical coefficient of the term 7 minus 16t. Here we have first we needed to identify. Actually here two terms are there, 7 minus 16t. But that variable is in only one term. What is that? Minus 16t. So the term is minus 16t. They told you to find only numerical coefficient. Here what is the numerical coefficient? Minus 16. Okay, once again listen. They told you to find the numerical coefficient of a expression 7 minus 16t. Here variable is in only one term. So minus 16t. So our term is minus 16t. The numerical coefficient is minus 16. Sometimes 2-3 terms are there with the variables, means we can take it separately. Okay. Then see about like terms. Terms which have the same algebraic factor are known as like terms. That means a term with same variables. Same variables means we can call that as a like term. Example 6xy minus 8xy 100xy. Now in these three terms the variable is same, right? Don't go check the numbers, only see the variables. xy 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 three terms, all the three terms have the variable xy, so we can call these three terms as a like terms. So only needed to check the variable, right? Okay, unlike terms means opposite of this. Terms which have different algebraic factors or unlike terms, different variables. Okay, see example 6xy minus 8x 100y. You may think xy it is like that, right? But if a term have xy means remaining all terms must have only xy. If it is so only, we can call that as a like term. But here see, first term it is xy, second term it is x, and third term it is y. So unlike, right? Okay, are you clear? Like terms means all the terms must have the same variable. Unlike means it variable was differ or missing, means we can call that as a unlike terms. Then about types of expression. See, an expression with only one term is called monomial. So we are going to classify the polynomial according to the terms, number of terms. So an expression with only one term. Only one term means we can call that as a monomial. Example, say 15p. 17xyz. I hope you know the difference between terms and variables, right? Here only two terms, 15p, 7xy. That means two expressions was there. Each expression have only one term. So we can call that as a monomial. Then about an expression which contains two unlike term is called binomial. Expression it has two terms. Okay. Example, say ax plus y, or the first expression x plus y. X is one term, y is another term. Usually you know well how we will in an expression how we will split that terms with the help of plus and minus. Okay, so x plus y, that is x is one term, y is another term, so totally two terms. Second, m minus 5, m is one term, minus 5 is another term. Then 5xyz minus 12pqr, 5xyz is one term, 12pqr is another term. So each expression have two terms, so we can call this all expression as a binomial expression. Then one is trinomial. An expression which contains three terms is called a trinomial. So like above, that only two terms, here we need three terms. See an example, x plus y plus z is x one term, y one term, z another term. Then 7x plus 4y minus 6, 7x is one term, 4y is another term, 6 is another term. Then last one is 4p minus 6q minus 9s. 4q is one term, 6q is another term, and 9s is another term. So totally we have three terms. So we can call this as a trinomial because each expression have three terms. And finally, in general, an expression with one or more terms is called a polynomial. In general, we can call that as a polynomial. By classification way, we can say if it has only one term means monomial, two terms means binomial, and three terms means trinomial. Okay. Problems. See, write in the form of expression. Your own statement is given, we are going to write in the form of an expression. See, the question was numbers x and y both squared. So first two numbers are there, x and y. both are squared and added. We need to square the both numbers and answer. So squared means x square, y means y square. So what is our answer? X square plus y square. Both of them are squared as well as added. Okay. The next problem, see, classify into monomial, binomial and trinomial. So some expressions was given, we want to classify it as a monomial, binomial, trinomial. See, first 4x square y, 5xy minus x square plus 7, 7xy minus 9, 6x square, 5x square plus 12y square. So 1, 2, 3, 4, 5. 5 expression was given. Monomial means it must have only one times. So it is 4x square y only one time and 6x square. Okay. Then binomial. We needed to take an expression with have two times. That is 7xy minus 9 and 5x square plus 12y square. And finally trinomial. 5xy minus x square plus 7. It has three times. So trinomial. Okay. Okay. So children, today we just discussed the introduction part of the algebraic expression chapter. So we found what is variable, what is constant, then about what is how to make an expression, and what is how many terms are there in an expression, and about the finding factor, coefficient, yes, and types of expression according to the terms. All those things today we discussed, right? I hope you all understand. Okay children, thank you. Now we are going to add two or more expression, that is addition of a expression. Okay, so listen, see the first question, find the sum of t minus 8tz, 3tz minus z, z minus z. Find the sum of t minus 8tz, 3tz minus z, z minus z. Totally three expressions are there. So first we are going to add these three expressions. Okay, so first just we are adding the three expressions. See, t minus 8tz, then plus 3tz minus z plus z minus t. So we are going to add these three expressions. Okay, then what is the next one? Needed to arrange the like times. Okay, arrange the like times. T minus t, then 8tz plus 3z minus z minus z. So we arrange the like terms, that is t minus t, then minus 8tz plus 3tz, then minus z minus z. So first we are going to solve t minus t. What is that? 0. That is 1 minus 1 is 0. So we cancelled that. Then 8tz plus 3tz minus 8tz plus 3tz. First coefficient is minus 8, then plus 3. If two different sign means what we will do? If two different sign means we will put the greatest number sign and subtract it. Which is greater? Minus. So minus 8. So minus 8 minus 3, that is 5. So what is our answer? Minus 5tz, and minus z plus z will get cancelled. So what is your answer? Minus 5tz. Okay, then see the next problem. See, find the sum of 14xy plus 10y minus 12xy minus 13, 18 minus 7x minus 10y plus 8xy, 4xy. So totally three expressions. We are going to add these three expressions. Okay, so first just add it. So 14xy plus 10y minus 12xy minus 13 plus 18 minus 7x minus 10y plus 8xy plus 4xy. So we add all the three expressions. What is the next step? Arrange the like times. We are going to arrange the like times. Okay, so arrange 14xy. So what are the remaining xy terms? Minus 12xy, then plus 8xy plus 4xy. So first we arrange the xy terms, that is 14xy minus 12xy plus 8xy plus 4xy, then y plus 10y, then minus 10y, then numbers minus 13 plus 18, then only one term is there, that is x term. So we wrote minus 7x. Okay, so now we are adding. See, xy is a like term, so we are adding. See, 14 minus 12, 14 minus 12 is 2, then 2 plus 8, 10, 10 plus 4, 14. So 14xy then plus 10y minus 2y will get cancelled, then minus 13 plus 18, two different sign means we will put the greater number sign, that is plus. 18 minus 13 is 5, then x time is only one time is there, so we are writing as it is, that is minus 7x. Okay, so finally we got the answer 14xy plus 5 minus 7x. So first we add all the expression, then we arranged in the like terms. Okay, then we solved. We are going to revise subtraction. Okay, see, first question, subtract 6xy from 12xy. Subtract 6xy from 12xy. So first we are going to write in the form of subtraction, that is 12xy minus 6y. First we are checking whether these two are like terms or unlike terms. So see, xy, so it is a like term. Okay, so just subtract the coefficient. What is 12 minus 6? 6. Okay, so what is your answer? 6xy. So 12xy minus 6xy equal to 6xy. Okay, so one more problem. See, subtract 5a square minus 7ab plus 5b square from 3ab minus 2a square minus 2b square. So first we are writing what? The subtraction form. So 3ab minus 2a square minus 2b square. Always you children committing mistake in this place. Minus of subtraction. So minus of remaining all times. Minus of 5a square minus 7ab plus 5b square. Then want to multiply the minus inside the bracket. Okay. So we will get 3ab minus 2a square minus 2b square, minus into plus minus, so minus 5a square, again minus into minus plus 7ab, then again minus into plus minus 5b square. Okay, so what we got, we multiplied the minus inside, so we got minus 5a square, minus into minus plus 7ab, minus into plus minus 5b square. Okay, then we needed to arrange the like terms. So 3ab, then one more ab term is there, that is 7, so plus 7ab, then minus 2a square, another one b square term, that is minus 5b square. Okay, then a square term minus 2a square minus 5a square minus 2b square minus 5b square. So we arranged all the like terms. Okay, now see, just to solve it, 3ab plus 7ab, 3 plus 7, 10. Then remaining full of same sign. If it is same means we can put the same sign and add. So minus 2 plus 5, 7a square, and again minus 2 minus 5, that is minus 7b square. Once again just listen. First we are subtracting, so first we are multiplying the minus throughout, then we are arranging in a like term, that is 3ab plus 7ab minus 2a square minus 5a square minus 2b square minus 5b square. 3ab plus 7ab is 10ab, then minus minus, so minus 2 plus 5, 7, 7a square, again minus 2 plus 5, 7b square. Okay, then next about value of an expression. Just we are applying the value of variable and getting the value of an expression. Okay, see, the value of the expression depends on the value of the variable from which the expression is formed. Okay, so just we are applying the value of the variable to the expression and finally we will get the value of the expression. So just we are going to see some problems. See, first one, if m equal to 2, find the value of m minus 2. So we know the value of the variable m, that is 2. So in this expression, in place of m, we want to apply that. That is m minus 2. That is 2 minus 2. In place of m, we are applying 2. What is 2 minus 2? 0. Okay. So what is our answer? 0. So 2 minus 2 equal to 0. Then one more problem. See, 3m minus 5. 3m minus 5. Just apply the value of the variable here. What is the value of the variable? That is 2. So in place of m, we want to apply the value 2. So see that 3 into 2 minus 5. 3 into 2 minus 5. So just we are multiplying. 3 2s are 6. 6 minus 5. What is 6 minus 5? 1. Yes. So first we applied the value of the variable, that is 3 into 2 minus 5. 3 2s are 6. 6 minus 5 is 1. Okay. And one more problem. See, if z is equal to 10, find the value of z square minus 3 into z minus 10. So just first we are going to simplify this, then we are applying the value of z. Okay, so what is the given expression? Z square minus 3 into z minus 10. So first we are going to solve the numbers which is present inside the bracket. Okay, just multiply the minus 3 inside, just multiply minus 3 inside. So what we will get? Z square minus 3 into z is minus 3z, minus 3 into 10, minus into minus plus, plus 3 tens are 30. Okay, now we got, right? Then apply the value of z. What is our z value? 10. So apply the value of z. So our expression is z square minus 3z plus 30. So in place of z, 10. So 10 square minus 3 into 10 plus 30. 10 square minus 3 into 10 plus 30. So what is 10 square? 100. 10 into 10. What is the meaning of 10 square? Multiplying 10 2 times. 10 into 10. So 100. 3 into 10, 30 plus 30. Here minus 30 plus 30 will get cancelled. So finally what is your answer? 100. Okay. So next we are going to discuss number pattern. Okay, number pattern. So usually number pattern means a general form in puzzles. We are going to do that. Okay, so see, first number pattern. For example, we are selecting a number, a natural number n. Okay, so consecutive terms are success or what nested term. If one is there means what is a nested term? 2. So in general how we will write? Here the term is n. So nested term is n plus 1. Okay, for example, the term is 5. Okay, now it's a nested term 6. How we can write? 5 plus 1? 6. It is n plus 1. Okay, so successor, the nested term we will say it is a n plus 1, that is 6. Okay, then next one, even number. All even number we will say it as a 2n. All even number we will call it as a 2n. 2 is a even number, so if you are multiplying any number with these 2, definitely we will get a even number. Okay, so that is 2n is a even number. So odd numbers, how we can write odd numbers? That is 2n plus 1. Okay, 2n plus 1. If you add any even number with 1 means definitely will get an odd number. Okay, this is some of the general terms, that's all. So we will see an example. See, just write the general pattern. See, what is, they gave a series like 3 6 9 12. So all these numbers, its own common thing is there. What? All are multiple of 3. So we can write 3n. Okay, 3 into n. Suppose it is given like 5 10 15 means our answer is 5n. Okay, see, it is a multiple of 3. All these numbers are multiple of 3. So how the general pattern? 3n. Suppose all these numbers are 10 20 30 40 means all are multiple of 10. So what is your answer will be? 10n. Okay, so it is a common. Then one more problem. See, write the end term. Here one series was given. Sorry, sequence was given. In this sequence, we are going to find the general end term. How it will be? 11, 21, 31, 41. 11, 21, 31, 41. All these common is plus 1, plus 1, plus 1. Okay, what is that? 11, how will write 10 plus 1? 21 is 20 plus 1. 31 is 30 plus 1. 41 is 40 plus 1. Okay, so in general term, how we can write 10n plus 1. Okay, 10n plus 1. Okay, children, I hope you all understood what we discussed today. Okay, today we revised the whole chapter algebraic expression. I hope you all understood. Okay, thank you.